Welcome to part 3 of Google Associate Data Practitioner Full Crash Course. In this video, we're gonna cover designing a Google Cloud infrastructure part. If you not already subscribed, please subscribe to our YouTube channel. For all the latest real exam question and answers PDFs, please visit www.shapingpixel.com. Welcome to designing a Google Cloud infrastructure. In this video, you will learn how to build an enterprise IT solution using Google Cloud Platform, or GCP. To get the most out of this guide, you should already be familiar with the core components of GCP. We will use a case study to demonstrate how to apply enterprise principles to your cloud design. The process begins by taking your organization's requirements and translating them into the right compute, storage, and network components on Google Cloud Platform. You will see how to assemble these building blocks to create an enterprise-class application architecture that is both robust and scalable. High availability will also be a key focus, ensuring your solution remains reliable. Next, we will cover how to secure your environment. This includes authenticating users and applications, assigning permissions, encrypting your data, and meeting strict security standards such as the Payment Card Industry Data Security Standard, or PCI DSS. You will learn best practices for protecting your cloud resources and maintaining compliance. Finally, we will discuss designing a solution that can recover from disasters, ensuring business continuity. We value your feedback, so please rate this course when you finish. Thank you for joining us on this journey into Google Cloud infrastructure design. Great Insight is a company offering web-based interior design software with both subscription and ad-supported free versions. After 5 years of steady growth, they have secured new funding and are now expanding rapidly, especially in North America. Their technical environment started with Microsoft systems, but now mainly uses a LAMP stack. The only Microsoft components left are for payment processing and Active Directory. Their databases include MySQL for the main application, Microsoft SQL Server for payments, and a NoSQL database in development. All systems currently run in a single data center. With growth accelerating, Great Insight faces several challenges. They need to scale quickly, improve reliability, and enhance security. Their disaster recovery plan is slow, and their infrastructure cannot keep up with demand. They must also maintain PCI DSS compliance for credit card processing, which is handled by a certified payment processor. The company's main goals are to move as much infrastructure as possible to the cloud, connect their data center to the cloud securely, encrypt all data, and design for high availability. They also want to reduce disaster recovery time from a day to just a few hours. By migrating to the cloud, Great Insight aims to boost performance, reliability, and security while reducing management overhead and preparing for future global expansion. When choosing compute options on Google Cloud, you are not limited to virtual machines. Let's quickly break down the main choices: App Engine, Kubernetes Engine, and Compute Engine. App Engine is perfect for new applications where you do not want to manage infrastructure. It automatically scales resources for you. However, migrating existing apps can be tricky, especially if they rely on unsupported languages or operating systems. Kubernetes Engine is ideal if your app already runs in containers, like Docker. It offers flexibility and scaling, but you need to configure it yourself. It is not suitable for apps that require specific operating systems, such as Windows. Compute Engine gives you the most flexibility. It is best for existing applications, especially those that need specific hardware, operating systems, or cannot be containerized. However, it requires more management than the other options. For our case study, Great Insight needs machines with specific vCPU and memory requirements. Google offers predefined and custom machine types, plus flexible licensing for Windows and Linux. You can use Google's pay-as-you-go licenses or bring your own. On Google Cloud Platform, or GCP, you have several storage choices for your instances. Standard persistent disks are affordable but slower, using magnetic drives. Balanced persistent disks use solid-state disks, or SSDs, offering a good mix of speed and price. Performance persistent disks are even faster, while extreme persistent disks target high-end databases. Hyperdisk provides configurable performance, and local SSDs deliver the highest speed, but are temporary and risky for important data. For most workloads, balanced persistent disks are ideal. They're faster than standard persistent disks and cost less than performance persistent disks. Plus, they're redundant, so you don't need mirrored disks. Database services on Google Cloud Platform. Cloud SQL is a managed relational database for MySQL, PostgreSQL, or Microsoft SQL Server. Firestore and Bigtable are NoSQL options, with Firestore excelling at simple, scalable data and Bigtable handling massive datasets. BigQuery is a data warehouse for analytics, while Cloud Spanner combines relational structure with horizontal scalability. For Great Insight's MySQL and SQL Server databases, Cloud SQL is the best fit, reducing management overhead. For their experimental NoSQL data store, Firestore is recommended, especially alongside App Engine for optimal integration. On Google Cloud Platform, or GCP, you have several storage choices for your instances. Standard persistent disks are affordable but slower, using magnetic drives. Balanced persistent disks use solid-state disks, or SSDs, offering a good mix of speed and price. Performance persistent disks are even faster, while extreme persistent disks target high-end databases. Hyperdisk provides configurable performance, and local SSDs deliver the highest speed, but are temporary and risky for important data. For most workloads, balanced persistent disks are ideal. They're faster than standard persistent disks and cost less than performance persistent disks. Plus, they're redundant, so you don't need mirrored disks. GCP offers 5 main database services. Cloud SQL is a managed relational database for MySQL, PostgreSQL, or Microsoft SQL Server. Firestore and Bigtable are NoSQL options, with Firestore excelling at simple, scalable data and Bigtable handling massive datasets. BigQuery is a data warehouse for analytics, while Cloud Spanner combines relational structure with horizontal scalability. For Great Insight's MySQL and SQL Server databases, Cloud SQL is the best fit, reducing management overhead. For their experimental NoSQL data store, Firestore is recommended, especially alongside App Engine for optimal integration. Google Cloud Networking is built around virtual private clouds, or VPCs, which are simply called networks. These networks help connect and isolate resources, making it easier to manage everything from small projects to large organizations. Resources are organized into projects, which act as boundaries for security and billing. Each project comes with a default network, but you can create up to 5 networks per project, or request more if needed. Networks are unique to each project and cannot be shared directly. Networks span all regions, but subnetworks, or subnets, are regional. Subnets group resources and define IP address ranges. Instances within the same network can communicate, even across subnets, thanks to automatically created routes. Subnets must use non-public, non-overlapping IPv4 addresses. Default networks include firewall rules that allow internal traffic and specific protocols like SSH and HTTP. New networks start with no firewall rules. Instances need external IP addresses to reach the internet, and static IPs are only charged when unused. Private Google Access lets VMs use internal IPs for Google services. To connect your company's network to Google Cloud, options include Cloud VPN, Cloud Interconnect, and peering. For most needs, Cloud VPN with Cloud Router is recommended, as it dynamically updates routes and securely links your on-premises network to Google Cloud. Securing access to your Google Cloud infrastructure starts with strong user authentication. By default, Google Cloud Platform requires a Google account. But as your team grows, managing individual accounts quickly becomes unmanageable and insecure. To streamline access, organizations should use a centralized identity management solution. Google Workspace, which you might already use for tools like Google Docs, can also manage Google Cloud identities. If you do not have Google Workspace, Cloud Identity is a similar option built on the same platform. Most organizations already maintain a user directory, such as Active Directory or an LDAP server. The best practice is to synchronize this existing directory with Google Workspace or Cloud Identity. Google Cloud Directory Sync, or GCDS, is the simplest way to do this. GCDS copies users, groups, and other data from your directory to Google Cloud, running securely inside your network. Remember, synchronization is one way and must happen regularly. To make authentication seamless, implement Single Sign-On, or SSO. Google Cloud supports SAML 2.0-based SSO, allowing users to log in once and access everything. If your system does not support SAML 2.0, third-party plugins are available. For example, if you have Active Directory, use GCDS for synchronization and enable SSO. This ensures secure, efficient, and user-friendly access to your Google Cloud infrastructure. To manage access in Google Cloud, you assign roles to users, controlling what they can do with resources. Roles determine permissions, and you can assign them at the organization, folder, project, or resource level. There are 3 basic roles: owner, editor, and viewer, which apply at the project level. For more specific needs, Google Cloud offers predefined roles, which provide fine-grained access to individual resources. For example, the Cloud SQL Viewer role allows read-only access to Cloud SQL resources. When a user has roles at different levels, their permissions combine. For instance, if Marie is a viewer at the organization level and an editor at the project level, she will have editor permissions for that project. Follow the principle of least privilege. Only grant the permissions necessary. Assign roles to groups instead of individuals for easier management and consistent privileges. Control who can add group members or change policies, and always have more than one owner. A network administration group might get the compute network admin role. A QA team could have editor access on test projects and viewer access on production, or receive several predefined roles. Regularly audit policy changes using cloud audit logs to ensure security and compliance. When building applications on Google Cloud Platform, or GCP, you need a secure way for your apps to access the services they depend on. That is where service accounts come in. They help you avoid embedding credentials directly in your code. A service account in GCP is a special identity with its own email address and a public and private key pair. When your application runs, it uses this identity to prove who it is to other GCP services, like Cloud SQL or Cloud Storage. By default, virtual machine instances use the Compute Engine default service account, which has limited permissions. For example, it can only read from Cloud Storage, not write. To give your application more access, you need to assign the right roles to its service account, such as the Cloud SQL Instance User role. For example, if your Tomcat or IIS instances need to talk to a Cloud SQL database, you must create service accounts for them and grant the necessary permissions. The load balancer and web instances communicating over HTTPS do not require service accounts. As your architecture grows, you may need more service accounts. For now, understanding these basics will help keep your GCP application secure and well managed.
Protecting data starts with controlling who can access it. On Google Cloud Platform, or GCP, you have several options: identity and access management permissions, access control lists, signed URLs, signed policy documents, and Firebase security rules. To avoid confusion, use as few mechanisms as possible and always apply the principle of least privilege. GCP automatically encrypts your data both in storage, known as at rest, and while it's being sent over a network, known as in flight. All API communications use SSL or TLS channels, and every request requires a time-limited authentication token for added security. For data at rest, GCP uses 2 layers of encryption: data encryption keys and key encryption keys. By default, Google manages these keys, but organizations can choose to manage their own using Cloud Key Management Service, or Cloud KMS, or even supply their own keys for extra control. You can also encrypt your data before uploading it to GCP. This is called client-side encryption. Remember, if you lose your keys, your data is unrecoverable. If your organization handles sensitive data like credit card information, using Cloud KMS helps meet standards such as Payment Card Industry Data Security Standard, or PCI DSS.
Google Cloud Platform meets top security standards like SOC 1, 2, and 3, ISO 27001, and PCI DSS. It also complies with HIPAA, the Cloud Security Alliance Security, Trust and Assurance Registry, or CSA STAR, and the EU-US Privacy Shield Framework. Security on Google Cloud is a shared responsibility. Google secures its infrastructure, but customers must secure their own applications and processes. For example, both Google and customers play roles in network security, especially when protecting against distributed denial of service or DDoS attacks. Google offers features like default anti-spoofing, firewall rules, and Cloud Armor for DDoS defense. Customers should isolate deployments, use load balancing, and restrict public IPs. Google enforces API rate limits and resource quotas to protect all users. If you process credit cards, PCI DSS compliance is essential. Google Cloud holds the highest PCI DSS certification. Isolate your payment environment, use strict firewall rules, and limit access with Identity and Access Management, or IAM. Log all activity and monitor with cloud logging and cloud monitoring. Automate deployments, use configuration management tools, and install intrusion detection systems. Log every action, including admin commands, and export logs to BigQuery for analysis. Rigorous security design on Google Cloud helps protect your organization and customers from damaging incidents. Disaster recovery in cloud architecture is about preparing for the unexpected, from database corruption to hardware failures. Even small incidents can have big impacts, so planning is essential. 2 key terms guide disaster recovery. Recovery Point Objective, or RPO, is the maximum acceptable data loss window. Recovery Time Objective, or RTO, is the maximum downtime your application can tolerate. If you use Cloud SQL for MySQL, enable automated backups and point-in-time recovery. This lets you restore your database to a specific moment before corruption. For SQL Server, Cloud SQL supports automated backups, but not point-in-time recovery, so you can only restore to the last backup. Running databases on Compute Engine, you must set up your own backups and transaction logs. Use a service account with the Storage Object Creator role to copy backups to Google Cloud Storage. Custom disk images can speed up recovery and help meet your RTO. For extra resilience, replicate your database to Google Cloud and use monitoring to trigger failover. Hybrid solutions can split traffic between on-premises and cloud using DNS with weighted routing for seamless disaster recovery. Disaster recovery planning is all about balancing cost, complexity, and downtime. The right solution depends on your business needs and risk tolerance.
Thank you and see you in the next part. If you're not already subscribed, please subscribe to our YouTube channel. Check out our website for the latest real exam question and answers PDFs. Happy learning!